Okay, I'm going to talk about this in a variety of ways. They're certainly getting more difficult. What I'm going to suggest is this is what's known as a Diophantine equation, which means there will be integer solutions to this, and we'll talk about that more later, not so much in this section. Now, granted, this might be going overboard, but the one thing I would recommend you do is just pick easy values first, and I'll go through that with you. So you get x and y, and if I chose x to be 0, well, this is getting a lot simpler for me. What I'm going to get, for y, I'd get, 72. I'll write this down. Maybe I should write the work down for you. So if x is 0, you get minus 27y equals minus 72, and y, and that's if x is 0, by the way. That would be, let's see, 72 over 27. That's divided by 9, by the way. And what are you going to get? You're going to get 8/3. Get my eraser out. I believe that was an easy point to choose, and let's pick another one, right? I'm going to pick y to be 0 now. And if you do that, what do you get? You get 16x equals minus 72. And what do you get there? You get x equals minus 72 over 16. Well, let's take a look at that. That's going to be minus 9 halves. Right? Don't be discouraged by this. A lot of students look at the fraction, I'll never be able to graph those guys out. Let me get my eraser out. I want to point out these points are being listed. For example, this point is being listed here, and this point is being listed here. If you want to graph those points, which is not a bad idea, by the way, I mean, it can be done. Like, for example, I want to point out 8/3, 2 and 2/3. So what does that mean? When x is 0, y would be 2 and 2/3. Well, this is 2 and 2/3 up right there. What's the other point going to be? Well, it's along the x-axis. It's minus 9 over 2. And that's minus 4.5. Can I locate that point? Yeah, it's dead center between minus 4 and 5. Then what do? Get your ruler out and graph it. All right, I'll put this over here. Again, I'm not very good at drawing lines, to be honest. Even with a ruler, I'm not good at it. Let's put a little, I've got that off, don't I? You're never going to get it perfect, I'll tell you that now. I'll put this over here. I'll get rid of my ruler, and I'll do this over here. Now, remember what I said in the beginning. You're done, by the way. If you don't want to listen further, don't listen any further. What a lot of people do is they want to get integer solutions to the problem. And there's conditions under which there will be integer solutions to the problem. And I'm going to claim this is Diophantine. So when I'm looking at it, the first thing I would do, and again, you may disagree with this, I would divide both sides by minus 72. And if you do that, you get minus 16 over 72, x. Then you get plus 27 over 72, y is equal to 1. And then I'd reduce it. And I'm noticing, like for example, on the first term, a division by 8. So I can put down minus 2x. And again, this is something that you don't need to do, but I'm going to say we need to go in this direction at some point. So I'm dividing by 8, right? So it'd be 9. And what do you get over here? Well, let's see, plus, I'm going to divide by, let's see, 9, right? So 9 goes into 27 3 times, and it goes into that 8 times. Now, granted, I realize that people looking at it, I don't know what to do with that. Well, I'm seeing what I believe to be an obvious solution to the problem that's integer. For example, x is 9, and y is equal to 8. And that's an integer solution problem. This is definitely Diophantine. The beauty of Diophantine equations is this. If you can find one solution, you can find infinite number of solutions to the problem. All right, so before I celebrate this, I want to point out, I would like to check to make sure that's an answer to the question. Right, so I'm going to plug it in. 9 times 16 is 90 plus 54. And let's see, 27 times 8, minus 160. And 7 times 8 is going to be 56. The question is, does that equal minus 72? Well, let me go through that with you. 90 minus 160 is going to be minus 70. And 54 minus 56 is minus 2. Of course it equals minus 72. So I'm going to erase this. I'm pretty convinced that the answer I got is 100% correct. All right? Now, remember what I said? There's an infinite number of integer solutions to the problem. I got one. I'm going to use this one to get another one. So someone goes, how could you do that? Well, the way I'm going to do that is I'm going to do what's called a table. Let me put the table down for you. And we'll talk about how to do this. This is x, and this is y. And I put 9/8 down. Right, and there's going to be something in your futures, and something I would say pay attention to, but if you're not clearly catching on, that's fine. What I'm going to do for this equation over here, I'm going to solve it for y, and you're going to get 16x plus 72 is equal to 27y. What I'm going to do now is divide both sides by 27, and you can get 16 over 27 x plus 72 over 27 equals y. Now, before you do anything, I know this is difficult, what I start to realize is that all I have to do is pick a very simple number, right? A very simple number. And, looking at it, a simple number, and I know it's difficult for x. Let's take a look. All right, so I'm looking at that. What I should probably do is reduce 72 over 27 for you. And would that help out? I write a little differently. 16x plus 72 over 27. But what I want to point out, what I'm going to do is just march up 27. That's all I'm going to do. So what's 27 plus 9? That's going to be 36. All right? I marched up along the axis. Now, the question is, what would the y march up by then? All right? So let's take a look at that. It would go up by 16. That would be 24. Let me get my eraser out. And I have another integer solution to this. Before I say anything, though, I want to point out I clearly see a pattern over here. So 9 to 36, it went up 27. And 8 to 24, it went up by 16. Let me get my eraser out. I think I'm done with this section over here. I think I'm done with this. And by the way, we can also go backwards. So instead of going 8 to 24, I could go 24 to 8, which is down 16. Well, what's down 16 from 8? Minus 8. Okay, what's down 27 from 9? Minus 18. And you could do this game all day long. The thing is, you're generating integer solutions to the problem. Let me just go through this with you, make sure you understand what we're doing over here. I'm seeing a pattern. It's an integer pattern. It's one you're going to have to pay attention to later on. We've already verified this. I'm going to verify the other two now. Right? How would I do that? By the way, these are tough to plot too. I'm not saying they're tough to plot. They're easy to plot. Bottom line is they're definitely on the plot. I just don't see them at this point. And why is that? 9/8 is off in the distance. 36/24 is definitely off in the distance. What's nice about integers, though, they're kind of easy to get the pattern to it. And they really are. They're very easy pattern problems. So I'm going to check it. And I'm going to check, let's see, which one I'm going to check first. I think I want to check this one first. All right, let's write this down. So what's it going to be? I'll write this over here. 16 times minus 18 minus 27 times minus 8. And they said it's equal to minus 72. All right? Well, I'm going to divide both sides, just to make my arithmetic easier, by 9. I'm dividing by 9. And now I'm going to divide both sides by 8. Minus 4 plus 3 equals minus 1. That worked. By the way, we checked this one before. Let me check the other one. And again, I know this is difficult. I'm not saying it's going to be easy for you. Let's put this one down. And what do we have over there? We have 16 times 36 minus 27 times 24. And they said it's equal to minus 72. Well, you know what? Those numbers are outrageously big for me. So I'm going to try to reduce the complexity of the problem by dividing both sides by 9. Now I'm going to divide both sides by 8. And whoops, sorry about that. I get my eraser out, I got excited. I said I divide it by 8, right? So what do you get over there? 8 minus 9 minus 1. It works beautifully. So again, what I'm pointing out is that, you know what? It does take effort to get an integer solution to a problem that's diaphantine. Sometimes it takes a lot of effort, and we have methods for it. But the bottom line is once I do that, I can start to generate a tremendous number of points from it. Are these points difficult to plot? Yes, they are. So keep in mind that even though fractions may look difficult to you, it may be in your interest. If you can see how much work was over here, work that we'll need to do later on, because we're very interested in integer solutions of diaphantine equations. But the bottom line to graph, don't avoid the fractions. It's very easy to deal with a fraction. Thank you.